Hello everyone, welcome to MathPrax, and welcome to the 6th video in this Arithmetic Progression Practice Problem series. Last time we looked into microcontroller flash memory address calculations as an arithmetic progression. Here we'll see how some day-to-day physics can be viewed as an arithmetic progression as well. Here goes the problem. A bullet train started accelerating uniformly at 2 meters per second squared when its speed was 36 kilometers per hour. If it kept its speed constant after 50 seconds, how fast would it go? If it started decelerating at 10 meters per second squared, how many seconds would it take to reach full stop? How do we view this velocity and acceleration problem as an arithmetic progression? Let's say any relationship between two variables that can be expressed in a linear equation can be viewed as an arithmetic progression. When an object uniformly accelerates, the speed or velocity changes. And these different velocities can be thought of as the general term in the progression. That would be a sub n in the formula. The reference term would be the initial velocity, n would be the elapsed time, and acceleration as the common difference. But since time is involved, the reference term used will be the zeroth term, meaning that is the value at the moment it started changing. And now you can think of the formula as velocity sub t equals initial velocity plus time multiplied by the acceleration, which exactly is the formula for the velocity of a uniformly accelerating object. Let's now collect what we can use in the formula. The initial velocity would simply be 36 kilometers per hour. But because the acceleration is expressed in meters per second squared, we'll have to convert the units so they are the same. Depending on the problem, you are going to have to choose which unit to convert to. For this problem, I arranged the values so that it is convenient to use in meters and in seconds, instead of in kilometers and hours. So let's do that. Multiply this by 1 hour over 3,600 seconds and 1,000 meters over 1 kilometer. Then, the initial velocity in meters per second is 10. Let's put the acceleration here as well. At this point, there are two variations. Either solve for the velocity at a given time, or solve for the time to reach a certain velocity. I guess we are ready to answer the questions here. What is the speed after 50 seconds? The answer would be 110 meters per second, and that is 396 in kilometers per hour. The other question, if it started slowing down at a rate of 10 meters per second squared, how many seconds would it take to reach full stop? At full stop, velocity equals 0 meter per second. Since there is nothing else mentioned, this would be the velocity when it started decelerating. And so, we simply have all the given here. Solving for t gives 11 seconds. Problem solved. Now here's a follow-up question. Given v sub 4 equals 20 meters per second, v sub 22 equals 74 meters per second, what is the acceleration? The answer is 3 meters per second squared. Thank you for watching, and if you found this video helpful, please hit that subscribe button so you don't miss out on my next tutorials. I'll see you in the next one.